Hi everyone, welcome back. Today we're going to talk about the Neural Style Transfer project, which began about a month ago on Charming Data. The goal of the project was to raise awareness of the plight of artists who suffer from AI-based style theft, where their artistic styles are being plagiarized without their consent. And this leads to the loss of income, the loss of livelihood for all these artists. On the screen, as you can see right now, we have a brief demo of the style transfer sandbox for artists. So first of all, Dilek is going to upload the first image content. Edit this out. And then we're going to upload the second image, which will be the style. And once Dilek clicks the style image button, what's going to happen, it's going to transfer the style from the image on the right to the image on the left. This is done through TensorFlow and some pretty neat algorithms developed by Shaf on the back end. So while this is loading, because it's kind of spinning up the server, let me introduce you to Shaf and Dilek. Shaf is an engineer at the New York Times, and he works on the New York Times Games platform. He has a research background in computer vision and AI-based computer vision techniques. He has also previously worked for the Department of Defense, the NBA, and Business Insider. Dilek is a developer and artistic illustrator. She has created illustrations for various publications and musical acts, such as Scientific American, The Intercept, and The Grateful Dead. In the first part of this presentation today, Shaf is going to share the initiative of the project. Shaf is going to give some background to the concept of style transfer and attribution. And then he's going to walk us through two different notebooks, the implementation notebook and the service endpoint notebook, which highlights how to turn collab into a service and exposing it into a Flask endpoint. And then in the second part of this presentation, we're going to have Dilek. Dilek is going to go through the front end and demo the style transfer sandbox for artists and also style attribution, and share with us some closing remarks. Now, most of what you're going to see here today is going to be accessible on in the description part of the video, the notebooks, the application. And if you have any questions, please feel free to ask them in the comment section of the video. All right, so as you can see, the style did transfer pretty neatly. The image on the right, the style of it is now on the image on the left. And I remember when I saw this like for the first time, I was like really surprised. Like, how can we do this with like TensorFlow and the algorithms and all the mathematics that I never really excelled at? And now, boom, you just have that style transfer. But back to the point, this really hurts artists, and this is one of the main reason why we took on this project in Charming Data. And so I'm actually really happy that we took this on. Thank you, Shaf, for bringing this project together, for talking about it, Dilek, for joining from the very beginning, pushing this. I'm really glad we developed this project together, this application. Shaf might even come out with a research paper out of this. So this is the idea of Charming Data, right? Doing projects that can help the public good, and this is what we've done with this project. So now I'm going to pass it on to Shaf to talk to us a little bit about the initiative of the project. Shaf, the floor is yours.
Thank you. Thanks, Adam, for that introduction, and thanks for that demo, Dilek. So yeah, the initiative of the project is based on, as Adam initially had outlined, helping artists cope with and figure out ways to cope with the style transfer problem. Now, style transfer, again, on its own it's a very novel and interesting technique, and it has lots of legitimate applications. But one of the categories and the concerns of ethical AI is to highlight this issue and make sure people who have generated the art, humans, are attributed properly for the art that they create. So what we attempted to do was start a process of figuring out how we could demonstrate the problem, and investigate a potential solution. Now, the problem itself is wide scale. This can be done very easily. Style transfer mechanisms are all abundant on the internet, and it's pretty easy to do this using a few simple libraries, or just a bit of in some involved Python coding, but it's just straightforward to set up a system to do this. And essentially what happens is that you get systems out there like style transfer engines, where people can look up the images of artists who have been are not actually generated by the artist, but it's applied, their artistic style is applied to the image, and then because somebody likes that style, and then that image is then purchased, or plagiarized, or misappropriated that style, whatever the case is, and then sold without the artist's consent and without the artist's accreditation for that particular piece. So this is essentially a very large issue, and what we try to do is come up with maybe some ways to chip at the tip of the iceberg here. So what I'm going to do is I'm just going to go over some of the basics of this whole thing in these slides, and I'm going to talk about not the main solution, but like more like how we can approach the solution or a solution, and like build upon it. So style transfer itself, for anybody again you've seen the demo, again, it's typically done through tools in the public, like Stable Diffusion and a few other tools that where you can say, I want to create an image in the style of a particular artist, and you can see that, okay, this image is now generated as Michelangelo in the style of a car, Van Gogh, the car in the style of Van Gogh, and then so on and so forth. You can see that, and the reason I chose the car is because at that time period, cars didn't exist. So you can apply this style to any kind of image. So visual AI are trained to recognize particular styles and categorize these styles, and then, similar to the process that was initially demoed, extract that style and apply it. Now, how is that possible? Neural networks over the last several years, especially visual neural networks, have essentially obtained the ability to extract style. And style is its own entity. It's its own computational entity. Without going too much into the specifics, here's an example of a network known as a particular type of network, VGG19, which is a very powerful network. It has been superseded, actually, but at the time that style transfer became a big thing, it was in the mid 2010s. This network was used to extract style from content. And so, roughly speaking, at a high level, the network is a convolutional neural net that's been pre-trained on ImageNet. And ImageNet is a data set of many different images obtained from all across the internet. The network itself can also be trained on artist-specific images. And without going into the details, roughly what's happening here is that the style and the content can be separated into different layers of the neural network. So you have the lower layers, the shallow layers, so to speak, and then you have the deeper layers. And the more wider or higher the layer is, the more it can capture the general geometry of an image, like that's distributed across the surface of an image. That would be things like brush strokes. That would be things like corners or high-level features. When you go deeper into the network, the geometry becomes more fine-grained and localized, and you can pick out specific objects, so shapes of different things in the environment. So those, roughly speaking, the shapes of the objects in an image are akin to the content, and the shapes of the general geometry of the image is akin to the style. And that's how the network computationally separates these two things. So here's a little bit more about the mathematics behind it, or the computation behind it. The style, this is all done statistically and through correlations on the network side. So again, the network is specifically called a type of network called a convolutional neural net. There's other types of networks which can do this, like vision transformers. The idea is that the style on the lower layers is extracted and put into this mathematical construct known as a gram matrix. The gram matrix itself is like a self-autocorrelational matrix, which identifies features within itself and helps to highlight those features that are applicable to a particular style. And the matrix operates at different layers. You apply the matrix operation at different layers to get different pieces of the style. And these are the visualizations of how the matrix imagery looks like. So if you were to like create like a heat map or like a intensity map, this is essentially the numbers that are associated with the rows and columns of the matrix. And that is extracted from each of these images here. So you have these 3 images, and when the style transfer process occurs, we essentially do this. Okay. Another thing to indicate is that we want to work on attribution. And how does attribution work? And attribution is the process where we want to say that this artist's style has possibly been applied to an image. And we want to say that, okay, maybe the image has maybe 80% attribution of the style or 90%. This is against a rough game because it's hard to tell differences between styles, right? It's not exactly a straightforward process because sometimes, and I'll go into a little bit about style mixing in the collab notebooks that I share, but essentially, you can have many styles that are similar to other people's styles. And again, there's different ways of trying to do the attribution. It's tricky, but part of this process is to kind of make some headway into figuring out, is this something that's reasonable that we can do? Is this something that can be built upon and made more advanced in the future so it can be used as part of a toolkit to help with the ability for artists to maybe use some sort of service to help identify that their work has been plagiarized or misappropriated. So the reason I'm bringing up the CLIP model is because the CLIP, which is an open source model, is used to I essentially use it in the attribution mechanism along with several other similarity metrics to extract the styles and do similarity checks between the styles of different images. So I'll leave it at that as to how that's working. And that also is like an intermediate process. This will likely advance in the future as the research advances in this more so. So this is going to may move to a different model altogether. So first, what I'll do,
Shaf, this clip model is this pretty modern model, or also from the 2000 and from the aughts?
Clip is pretty modern. It was released by OpenAI in 2021, I believe.
Oh, okay.
And its actual training is not fully known, and there's different sizes of the model. I'm using the smallest version of the model, actually, but more professional systems use larger versions of CLIP to do much more robust identification. So yeah, good question though. So basically, the notebook is I have a notebook for attribution here, and the work in this notebook is sort of my scratch work on how I could set it up. I have a more advanced playground where I'm doing more advanced techniques, but this is just kind of like the basics of the features that you're going to see being demoed later in the tool that Dilek has worked on to do some of this attribution work. So essentially what we're doing, we install our dependencies. I have all my dependencies installed right off the bat. And so there's a few demos here that I'm not going to run, that I have pre-run just to like demonstrate. We saw the demo in the beginning. So these are kind of the code that helps facilitate that. So for the neural style transfer, we're using a specific version of neural style transfer called fast neural style transfer. And there's a pre-built model to allow that to occur. That is essentially from TensorFlow Hub, called arbitrary image stylization. And again, that is a technique that is more advanced and uses different types of mechanisms to do style transfer. It's fast. That's why it's easy to demo. And it does things accurately and is tunable. So you can tune different parts of the model to have different pieces of style. And once the styles are extracted, what I essentially do is I load the final image. So I do a little bit of reshaping and I output the final image. And so if you have the content image and the style image, I just took these two samples here, this waterfall and this person, you get the final stylized image, as you saw in the beginning. So a little bit more that I did here was to do a little bit of the style mixing stuff. So I wanted to just use the same, and the reason I did this is that I wanted to be able to demonstrate how styles can be, they're computationally individual entities that can be combined and turned into whole new styles. And essentially what happens is that makes the problem a little more complicated if you are trying to do attribution. But for example, if I take the same image and I apply it to the content image, I get that stylized content. And then I take, for example, this image of Starry Night here, apply it to the content image, I get another image that looks like a Starry Night version of the content image. And then I can do combinations of images to combine the styles to have like a hybrid style. So again, stuff like this can potentially throw off the attribution we're talking about, but it's good to highlight these because maybe those things can also be accounted for. So essentially, I also wanted to demonstrate real quickly that you can do this thing on videos as well, right? So if I run this, this is a video of me talking and saying something, whatever. And essentially what I do is that I apply this technique over several frames, and I'll explain the frames in the code in a second and what's happening. Finally, as you can see, the video sped up, but the style is applied to each frame. And again, this is a statistical technique. That's why you see the style fluctuating, but it's still applied. And essentially what's happening is here, I've broken down each of the frames of this video and applied the style individually to these frames and stitched them together. And that's basically what's happening here through each frame. And then I'm combining them and then outputting a final frame. So then the attribution work itself, which I think is the core piece of this work in terms of like how the backend works, is that I mentioned things like brand matrices. I mentioned similarity scores. So essentially what I'm doing here is I'm taking an image and actually taking two images, an input image A and B, extracting their styles, and then applying a bunch of similarity scores to their gram matrices. So the example of one of the similarity scores that I'm using is the structural similarity index, which is taking several color properties into account of images along with image geometry, specifically to get gram matrices, and then comparing those two using style similarity based on a weighted sum of the layers that are used to extract the style. Now that's a mouthful, but what I'm trying to say is because since the style lives at different layers of the network, you can weight the layers differently in order to extract more prominent or less prominent elements of what you could consider style. Now that in itself, is a more complicated thing to do than I have here. And again, in my more advanced research that I'm working on, right now I have the weighting sort of hard-coded for each of the layers. But essentially you want to have more advanced layers and techniques. You want to have more advanced ways of choosing weightings for the layers. So for example, if in this example, I have the style layers that I've extracted here from, this is the VGG network, and then the layer weights, which, you can see that there's percentages applied. I've sort of hard-coded them based on like, what could approximately be associated with styles, but there are more intelligent ways to do this. For example, you can do things like randomized search, hyperparameter search, things like that, which are things that I'm experimenting on elsewhere to get an even better score. And so the end result of all of this is just to essentially also, again, to get the features is of the style of a particular image is a little bit where I'm doing like swapping models, like trying to apply clip to get features, trying to apply other models to get features as well. And so here's an example, right? So if I have the original image and I have an image that doesn't look anything like that image, right? And then I have a similar image, you can see that this original Van Gogh image has about, in this case, about 64% style similarity, which doesn't look high. But again, the more that I work on this, the more my more recent scores are actually higher. I've achieved about, in many cases with these two images, like 80-something%. And the differentiation is actually can be really good too. For example, these styles only look 24% related. And the contrast between definitively related and not related is where all the like magic and where all the research goes into. But the fact that you can even do some kind of differentiation is promising. So, and
Chef,
also,
what's the? I see 24%. What's the? Are you going to talk about this later? Maybe image 14%.
oh,
8%. What does that mean?
so I wanted, yes, thank you for bringing that up. This is the style similarity is one thing. I wanted to differentiate it from the image similarity. So the image similarity is a whole different thing. That's the similarity of the two images completely together, like every aspect of the image. And I wanted to demonstrate that, like, if that you can differentiate image similarity from style similarity, right? Because the style similarity, these are two different images, and it's clear that computationally these are two different images in both cases. But even though these are two different images, their style similarities, right, are distinct based on the style of the image.
But in this case, for example, the image in the middle has a higher percentage of similarity, 14% versus 8%, because I'm assuming they're both like images of faces.
That could be, yeah. It's hard to exactly tell how the AI is differentiating, similarity, but I'm using like similarity indexes, and yeah, it could be because there's some facial structure that's similar, some geometric edges. But again, the point is that they're low, right? Like the image similarity, these are two clearly different images, and the AI agrees. This image looks more like this image. This image looks far less like this image, and you had a good speculation that it could be the facial structure that's really corresponding, because these are geometric techniques essentially at the end of the day. Yeah. And so again, here's the style matrices. Again, just to point out the styles and not the images. And you can see that the style matrices from it's hard to tell exactly, right? Like with the human eye, but I just colorize these according to their like percentages to kind of indicate, like, you can see that the style matrices seem to be more similar for the images that are of similar styles as opposed to the images that's of a far different style. Okay. So now these are two representative samples. I've tried over several different samples, and I found that it works fairly well for many things. It can be thrown off for some other things. Ideally, in a perfect world, we'd get the most perfect score if possible. But again, this is research that we're just trying things with. And then quickly, what I wanted to do is just go over that other techniques that I've been trying were things like fingerprinting. So I wanted to see if I could do a digital fingerprint of a style. And so what that is everyone's familiar with digital watermarks for images. The entire image can be watermarked by applying some sort of like invisible transformation to the image under the hood. And the watermark, if somebody tries to copy that image, the watermark can be extracted, and that can be shown that that image was copied, was somebody else's, right? The invisible watermarking techniques are kind of like counterfeiting techniques, anti-counterfeiting techniques for like money theft or money counterfeiting. So similarly, I tried to do something for the styles themselves, seeing if you could actually put a watermark on the styles. Now, watermarks for styles are more complicated by far than watermarks for images. So one thing that I was investigating is that on a watermark in an image, you can hide the watermark in the image pixels. In the style itself, for styles, in order to get a more effective watermark, what I had to do was like hide the image in the, or hide the watermark, attempt to hide the watermark within the actual color frequencies of the image. So what I'm doing is called a spread spectrum frequency watermarking, where you're taking the frequencies corresponding to the colors of the image, and then attempting to spread the watermark throughout different frequencies. You can think about like you can do the same thing with music as well. Hide the watermark in particular octaves or particular notes or particular harmonics. And with images, it's more complicated because you have 2D data as opposed to 1D data, and you have frequency data. So essentially that's what this is doing. I'm computing the spectral transformation and hiding the watermark in the style itself, or in the spectrum of the style rather. And you can see in this example here, I do this style application. I can take the original fingerprint. Now, the similarity, I would not worry about this. It says similarity in -18%. This is just like a test. It actually has no numerical bearing. The point is that the fingerprint is transformed in a specific way once you stylize an image. And the goal is to be able to extract the fingerprint from the stylized image to compare it to the original image that is of a particular style with a fingerprint and determine their similarity. This is more of a work in progress in the attribution. It's more challenging to do this kind of thing because it's actually more fundamental research, but I just wanted to demonstrate. And so so that's with this notebook. And now I'm going to go to the server notebook real quickly. So the tool that Dilek has demonstrated and is going to demonstrate uses the services that utilize the functions in this previous notebook that you saw. And so what I did to make this easier is that I turned Colab into a service. So you can actually turn Colab into like an endpoint where you can, or a series of endpoints which you can call remotely, and you can execute it as a normal backend service, which is pretty neat. I'm using another tunneling service called ngrok to help facilitate this. And also, to be clear, once this service, I tested this service out using Colab to actually do the actual test and the actual work against the tool, I deployed it to GCP. So it created a legitimate cloud service on Cloud Run. But this is just for prototyping purposes. So it'd be easy to work back and forth between the front end and the back end. So this is all the setup for the back end. I had stub front ends here. By the way, if you use ngrok, you have to get an ngrok token, and then you can get a free ephemeral endpoint, so to speak. So I have just stub JavaScript code that I wrote to test this on my own before we turn that. I'm not going to go over that. That's just, again, stub code. But essentially what happens is I apply some of the same mechanisms here. And now this notebook is a smaller version of what I showed in the attribution notebook that I showed before. This notebook has like more lightweight versions of the functions. The actual service that I deployed to GCP that Dilek is using, or her tool is using, is actually got the more beefy attribution functions. But this is just to demonstrate kind of what I did. So I created a Flask service here, and I have endpoints in that Flask service, which do things like the attribution. So I'll have an attribution endpoint. I'll have a stylized endpoint, which does the NST stuff. Now, remember, the code in here is just a lightweight version of the actual code that's running. The more complex code is stuff that is in a different notebook for research in the midst of being worked on. And and then I have post endpoints to do the post request, which serves the data to the backend. The data is turned into binary blob data and converted via base64 imagery, I believe, and then it's consumed and then regurgitated. The final result is regurgitated to the front end. So that's how I return the values.
And Chef, one question, quick question. So if somebody actually wanted to use this notebook, because I know you said you will put this as a link under the video, they should open the link, make a copy of it, and then just update the ngrok token?
Yes, they can do that, right? And then they'd be able to use this notebook. And also, technically, this is just a server. I have a front end version of this notebook to do the front end piece. That's not sort of the middleware, really. It's like the front end that communicates with the post endpoints. But this is just like an example, because what is in this notebook is like the lightweight version of what I've actually put together for demonstration purposes. But essentially, it does the same kind of thing. So you have a bunch of different functions to do all the computations. And so I have the get endpoints, which correspond to the post endpoints, for actually receiving the HTTP request, rendering the front end, and then allowing the front end to send data to the post endpoint this is the get, and then that's what's called in the browser, and then the post computes the numbers and returns that back. Okay, so that is pretty much it from the stuff that I wanted to demo. I can now hand it back to demo the actual tool which implements and uses all this stuff.
Cool. Thank you, Shaf. Very enlightening. And I appreciate you not only working on this, but sharing the notebooks with us in the description of the video. So like you said, I'm gonna move it on to Dilek to actually show how this is done in the front end. Dilek, let me share your screen. 1 second. Stage. Okay, there we go.
Thank you for that amazing explanation, Shafiq. It's wonderful. So I'm just going to go through the decisions that were made in styling the front end and some other details. So I'm going to start with the neural style transfer sandbox. Now, my decision behind using a multicolor gradient for the background is just to create an aesthetically pleasing, whimsical environment for the user to play in. Since this is a sandbox, to familiarize the user with the process. And I used HTML, CSS, and JavaScript here. And for the font, I used Adobe Typekit. I'm a huge fan of their libraries. I selected Indivisible as it is a clean and modern sans serif, and it looks very balanced in the UI. I implemented clean buttons with rounded edges, and I added an animation tooltip just to give the user information on accepted file types for the application.
Nice.
And I added a thank you. And I added a gradient button animation to, imply the feeling of magic taking place to the user, because, it really is a kind of magic to somebody who is not aware of what's really going on under the hood here. Okay, so we're going to upload our content file. And I selected this image not only because it's stylistically very different from the style image, but because I can relate to it as well personally. So I'm going to upload the style image, and this is a drawing by Hans Bellmer. And we are going to stylize. And once the button element is clicked, the two images are checked. And if both meet the conditions of being uploaded via the API call that's happening, the lazy load animation I created is being displayed while the server is processing the images. And once the server fulfills the promise and responds with the results, the loading animation will be hidden and the stylized image will be displayed. And furthermore, if there are any errors, an error message will be displayed via try catch block in the JavaScript code. Not that that's going to happen now, but it's always good to keep in mind. And a try catch block is very good practice in an API call, as error handling is really important in your code and possibly in your life as well, because we all need a plan B. It's very important to keep that in mind. All right. And now the stylized image is displayed here at the bottom. And I did apply some resizing here to allow for the result to look balanced throughout the rest of the UI.
Resizing of what, of the front end, you mean, Dilek?
Of the image that the server responds with.
Okay.
Okay. And now we will move on to the style attribution. So for this, for style attribution, it is going to take two images and then display their style representation for each of the images that were uploaded. And that will display the gram matrix. And then within the style similarity div, it's going to display a numerical percentage of the how do I say this? To display how similar both styles are.
Okay.
All right. Okay, so, and both have a data tooltip as well here. So I'm taking a work by Van Gogh, and we're going to compare it to another work here. And let's just compare the styles. So same elements that are being used throughout all three of the applications.
What do you mean by same elements being used?
Just the colors and how I styled each of the buttons, the background.
Yes. Okay.
Just to ensure that everything's streamlined and belongs to the same concept. So here are the gram matrices that are displayed here.
And how much? What was the percentage?
74.63.
Nice. It's so funny that we get this high percentage, meaning like very high correlation, thanks to mathematics and TensorFlow, the Shaf build. But when I look at these styling, it doesn't mean anything to me, right? It's just like it's computer stuff. I mean, like I could never. It doesn't mean anything to me. Absolutely, it's like reading Chinese. Cool. Thank you, Dilek. Was there anything else you wanted to demo today?
Yes, there is.
Okay.
There is one more. And now this is the artist style finder, and we're using data that we currently have just for demonstration purposes only. So I'm going to select an artwork, and we're going to find artists and evaluate the percentage and similarity to that artwork. So here it is correct, or close to what is being uploaded here, 85%. Let's try another one.
What it's telling us here is that image, it's 85%, the probabilities are 85% that it belongs to Van Gogh.
Correct.
The previous image, okay. And this is because in the back end, it was trained on the images database that you were talking about, Chef. Were trained on Van Gogh images, the Monet images, Matisse. That's why.
Yeah, that's why it would be able to do this. And again, this is just for demonstration purposes. We don't want to actually do this. This is like a tool that somebody would use if they were doing that. But this is like just looking based on the style, being able to pick out the image based on the training of the network against that style. And that's actually done commonly. Networks are trained with particular artist style. Again, this is just demonstrating that. And we're saying that we are, this is a problem we're trying to avoid.
Yeah.
Right.
Perfect.
Yep. And I was able to go through all three of the examples that we have. So that's what I have for the front end.
Perfect. Thank you, Dilek. I know, Dilek, you wanted to close us out with some remarks. Before I move it to you, I want to say something quickly. Shaf, did you have any closing remarks? Anything you wanted to say?
No, I mean, I just wanted to say thank you for giving us the opportunity to work on this project. And I again, motivated, especially after talking to Dilek, other artists, just in general, about trying to figure out ways around this problem, because there is not, many people are looking into it, but it's not something that people take very seriously. To an extent, they are in little bits and pieces. There's more legislation getting built, but the legislation usually is in helping out the larger players who have the resources to prevent misappropriation of their styles. When it comes to the individual artists and the people often generating the work and making a living based on their technique, and that's alone, I don't think many people are actually looking out for them. There's a video, which we've included as part of the initial project, which indicates that actually, talking about like something like the greatest artistic style theft in history. I'd recommend watching that video just to get more maybe emotional and I guess intelligible context about the problem. But I think again, ethical AI needs to take these things into account. This is an area of ethics, because ethics in AI is hugely important, and we need to really make sure that the systems we build are not harming people. And in this case, a system that takes advantage of this very magical technique can and is harming people.
Yeah.
So we need to figure out ways to prevent that from happening. Yeah,
that's a very good point. And I'm also going to add that video that you shared a few weeks ago to the description area if people want to watch it. Dilek, did you want to close us out?
Yeah, as a artist and illustrator, I can definitely speak to this, and I am experiencing just the concerns and the fears that other artists are experiencing as well. Your style as an artist is something you hone during your entire practice of making images. It's as unique as your voice and your soul. And it's an extreme violation to take something so precious and sacred from an artist. Artists should be protected. And it's a struggle to be an artist. It's a fight to make the work sometimes. All artists know that we're vulnerable to being ripped off. The list goes on. Knowing that now AI can emulate an artist's style is very terrifying, and I hope this raises awareness to the problem. And to be able to explain this in a way that maybe programmers or people with a tech background can understand, people who don't consider themselves artistic, consider Stack Overflow and the answers that are accepted or top rated, which is a wonderful resource that I still continue to use. The programmers who write those answers spent their whole lives and careers getting to a point to write efficient and clean code. And their ability to do that is their livelihood. And I also believe that there was pushback on these answers that are used within this website and community, these answers being used as AI training data. So I believe that there is, something that people who are not artists can relate to there. And, maybe artists could be seen as frivolous to others because it's, perceived as more fun than writing code or solving leak code problems. But it was created by a human who made something, and that in and of itself has value. So,
Dilek, how, or Shaf, doesn't matter, how, for other people, maybe not artists, or people that are purchasing art online or images, is there anything that we can do to support this cause, to make sure that we're not buying stolen styles and that we're helping artists? Is there a particular method that we can do? Is something we have to be aware of? A particular website where we should go that's safe?
Off the top of my head, there's probably a few resources that we could share out. I've seen more and more websites talking about this. We could add them post video. But what I could say is that it would be whenever you're using AI art, and a lot of the times people now tag things as AI art generated, which is good, a good practice.
Right.
I mean, if you're going to use it, at least tag it. Many people do not, right?
Okay.
But I would then, if you are purchasing any kind of art, or if you're trying to brand stuff as I want to just create this thumbnail for this video, or I want to just apply this style, really think about, on a personal level, think about where that's coming from, right? Start to be is this ethically sourced, right? You can think of it as an ethical sourcing issue in a sense, right? I mean, in a similar way with food, etc. And also, I know that, for example, a lot of the image generators, I guess DALL-E now has guardrails to prevent generation in the style of a particular artist, which works. And that's actually, I would applaud whoever's made those decisions. I know, though, many open source models like Stable Diffusion and others do not, because they're intended to be as open and permissive as possible to do whatever you want and modify in whatever way you want. So again, the open source models are the big thing, and you can't always identify this. But what you can do is, I believe that it makes sense to do projects like this, raise awareness in this way, and talk to your representatives, talk to people. If you feel, even if maybe they may not understand the problem off the top of their head, this problem with AI is difficult to explain in many cases to people who don't have that background. But who may be in a position to help. I would say, maybe just talk to them, talk to people in the legal level, just bring it up as much as you can. Whenever you see people's art, people using AI generated art, just surface it, surface the thought. I mean, even if they didn't do it, even if the art is not like clearly a style or whatever, that's been still, I would speculate it as you can.
Right. Cool. Well, thank you so much, Shaf, Dilek. This was a pleasure. We're going to share this video and all the links and the resources that Shaf and Dilek talked about. We'll put that in the description. Thank you so much for starting this project, for taking this on, and for raising awareness, right, in favor of artists around the world. It was a pleasure to do this with you both, and I look forward to working on a different project with you in the future.
Yeah. And thank you again, and I really appreciate working with you, Adam and Dilek, on this, and great to like put this together and turn this into something. Y'all are great partners, and appreciate it.
Thank you, Shaf.
Yeah, thank you both. Thank you so much.
Have a good day. Bye-bye.